Hello, everybody. My name is Dick Blaze, and I live in upstate New York, along with Tom White, who is basically across the Hudson River from me. And we have been involved in education for a very long time. I have been a teacher, a principal, a department chair. I've worked in industry and was one of the co-founders with Tom White of Project Lead the Way. We developed that curriculum in a school district in upstate New York in the 80s and 90s. It became Project Lead the Way when the funding became available to make it possible for other schools to have it. And so we feel very privileged to be working with the Siemens Corporation in collaborating with them to develop what we think is the best STEM curriculum available at this time. So we're going to show you some of that. And Tom?
All right, so if I can just go ahead and share this presentation. Okay, so we're looking at the actual presentation now. And so what's going to happen is we're going to go through a few things. We'll give you kind of an overview of the program. We'll tell you why we think it's the best thing out there and why it's so important for young people to be involved in this. And then give you some information about how you can go ahead and get this at no cost. So I'll let Dick take over from here.
Okay. There's a term that has been out there for some time now called rigor and relevance. And in other words, what that really means to us is we want to make sure that the educational experiences that our students are getting are challenging, rigorous, but at the same time that they're relevant, meaning that they can understand the meaning and purpose for why they are needing to learn these certain concepts. Now, there's a next slide coming up where this is one of the technical drawing books that I have here in my office. And it's a very large book, and it has a lot of information in it. And it's likely the kind of a book that you probably should have in your class. You don't need a lot of them, just a few. And because there are times when you might need to refer to some drafting standards or some technical information and so forth. It's a great resource. But in this book, there are images like the ones on the right. And when we talk about rigor and relevance, when you look at those items on the right and the titles that are given for them, there is no relevancy to students of any of these parts. They mean nothing to students. And so what I find sometimes when I have visited CAD classes is the students are taking these images and they're putting them in their computers with the software they're using. And essentially what they're doing is they're learning the skills, knowledge and skills of software commands. And that is really not what we want to be doing. We want to be teaching problem solving and doing it through the engineering design problem solving process. And what you're going to see as we go through this presentation is you're going to see projects and problems that are presented to students that are in a domain of relevance to students, meaning that they recognize the terms, they recognize what they're doing. And, and we still deal with the skills of the software commands, but we do it in what we call just in time. So as the students need a particular skill at a certain point in the projects they're doing, we have the tutorials and the tools necessary in the curriculum to teach them that skill absolutely when they need it at that moment. And that's the best motivation there is for students to learn a particular skill. So having said that, let's see what this all looks like when you see a curriculum.
Well, what we try and do is form student teams. So the students are, as part of the design process, need to record everything that they're doing. So you'll see notebooks out with students taking notes, talking to each other. They do some team planning so they can learn how to work as a team and come to agreement on, what their solutions should be. And these are all those important soft skills that everybody says that they want, but it's very difficult to teach unless you put students into the place where they actually are doing those skills. And we think this is appropriate for all students as the teams work. It's really kind of nice to see as they develop things. A lot of things they do develop, they have to run by each other and see how they fit. There's a lot of collaboration. It's a noisy classroom. There's a lot of movement and people doing some, thought process in the way that young people are doing it now. We want to make sure that everybody knows there's no cost or fees to schools for the curriculum or the software. Siemens is providing both of those to schools at no charge. The school provides all the various and sundry components necessary, the computers and any other pieces of hardware that goes with it, but there's no charge for the software or the curriculum.
And Tom, let me add about the equipment. The criteria that we use for selecting what's needed to support this curriculum is this. The equipment needs to be durable, meaning that it lasts a long time, that it supports the curriculum, that it's affordable for schools, and finally, the fourth criterion is that it's safe for students to use.
Right. And it also has to be such that the students really want to use it. This equipment is no good if it looks good up on a shelf. It really needs to be in use as much as possible. So we designed this curriculum to make extensive use of 3D printing because it's a very quick and easy way to make parts. And part of design is to actually have things that fit together. So if all you're doing is drawing pretty pictures and you're not, forced into those conversations of how does my part fit with your part, then we're missing out on a vital piece of the education. So it's all project problem based, and there's lots of student choice in this. So there is no, you must make this part. The assignment for this one was you have to make an interlocking parts. So one piece fits on the other, they interlock and line up the same way every time. So this was this student's unique approach to this one. And again, you're going to see that precision measurement and pieces along those lines are really embedded in this, along with things like Excel skills. When we talk to community colleges and four-year institutions of higher learning, they have a whole list of skill sets that they'd really love the students to come in working with. So when we designed this curriculum, we talked to the colleges and said, okay, what are the skill sets that you think the students need? So we made sure that those fit into the projects. We also wanted to make sure that there was extensive use of being able to present in all kinds of different forms, everything from an elevator speech up to a formal presentation. And so this was one school's way of doing that. They invited the community in to the large gymnasium, and each student group set up a little table and they displayed some of the things that they were working on. So it really worked out quite well, because one of those great skill sets that the colleges told us that they needed was the ability to communicate with other people. They're using this engineering design and problem solving process that Dick spoke about. And this was a reverse engineering project they were given. Take a common everyday item, take it apart, measure it all up, and then see if you can recreate it. So the bottom picture is really a 3D printed clothespin. And this is the design process that we set them up to use. So there's, they have to do some basic research so they can come up with an understanding of what the problem is. They propose a number of solutions. They work it down to just a few. They design, they build, they test, analyze, and then the term iterate means they do it all again because no product ever makes it to market with on the first go round. It's always a continuous thing. And so there's 2 courses available right now. One is called the Siemens Engineering Design, and that's the first course. And the second course is Siemens Manufacturing and Automation. And you can download these for free. You just go to siemensdesign.tomwhitestem.com, and there's a short little form to fill out to basically register. And it ties the school in, and it explains how to get the free software for this, and you'll come up with all kinds of things. And what I'd like to show you is how these courses are really set up so you can get a flavor for what happens. So in course 1, which is the engineering design, in quarter 1, we start off with a small project to teach the engineering design process. So over the course of a week, they have a feeling for what it is that this process is. The second project, we teach them sketching and documentation. So they are learning how to use a pencil and paper in their notebooks. The third project introduces CAD systems and 3D printing. And so it's all just in time, one piece after another. And then once they get the basics down, then we give them a choice. So there's 3 projects here, and they have to pick one. And if you've been teaching for any length of time, you know that some kids are like rockets and other kids, they chug along. So these would allow different pacings in the classroom. And so all these groups could end at the same time. But basically, they all covered the same skill sets. They're just different ways of approaching it. And as you look at the names of these things, these are all familiar to students. Later on in that first quarter, we teach rendering, working drawings, and other forms of communication. And then we get into some more Excel work. It's called a table-driven part. So you basically have an Excel spreadsheet that works with the design. So all the information for the products can be pulled from a table. And the last project is an optional project, but a lot of schools really like this one. It's a package design. So it gets into sheet metal or what the mathematicians call nets. So something that folds up and becomes a product. Quarter 2 is when we begin assemblies. So they're basically learning how to document and pull things together to show people how it's all done, how to explode an assembly to show how it goes together. So the first one is a 3D puzzle, and students go off and they pick another teacher. So one classroom that I dealt with, the students went and interviewed kindergarten, first grade, second grade teachers and said, what are the types of things that students would benefit from? And they designed puzzles for those particular age groups. Then we took them through how to build a mold design. This one is basically for a chess piece that they designed in the first quarter. And then we have them, actually cast in the form. So they're melting chocolate or something similar to it to form a molded piece. So they learn about molds, and if you can design it, doesn't necessarily mean you can get the part out of the mold. Then we have another project where they go off and they have to design a coach's cart that carry stuff from the school building out to the fields and things. And the final piece is a reverse engineering presentation So they learn how to disassemble something, to measure it all up, and create all the drawings and pieces that go with that. And then they mount it all up on a nice looking display, board, so they can see how everything that goes into one particular piece.
15 minutes left, Tom.
In the third quarter, we've got them working with simple machines to begin with. So they're going to pick either a bathroom door launch or a nutcracker, and they'll go on to a ball launcher, which is another way of utilizing Excel to do some predictions on where things are going to land. There's a differential gear design, which kicks off the mechanical systems. So they're actually learning, what gears are all about, how to produce them and build something. And then we have them design a merry-go-round, go out, interview kids and figure out, well, what should this merry-go-round be like to keep kids happy? In the fourth quarter, we start off by having the students design a pedestrian bridge. So they talk about trust systems and basically analysis, so how do we know if something is strong enough? We then have them design a hybrid toy connector. So if you want to connect your Legos to constructs or something like that, well, there's got to be something that goes between them. So this allows them to do that. And then we follow that up with a playground design, so they can begin with their merry-go-round and design other pieces, which forces different groups to talk to each other. How does my piece fit into your piece? How much space do we need? What are some of the things that impact design, like the American with Disabilities Act and that type of thing? And then finally, they pick an engineering system project. So there's a choice of 5 different ones there. And this kind of shows them that we can go from just beginning to learn about how do we do the basis of design and stuff. And then we take them all the way through, how do I design my own part of something that works for me? The second course is all about manufacturing. And the very first quarter of the second course is all about design for manufacturing and assembly. And so there's some things that they understand to go ahead and create some of these projects. What are what do we need to do in order to manufacture something? So it makes it a whole lot easier to think about, how to put a product together if it only goes together one way. So there's no putting a part in backwards and that, things along that line. Quarter 2 is when we get into some CAM work, and there is a Siemens product. It's called Solid Edge CAM Pro, and it's a very robust tool path generator. So they have to understand G&M codes, speeds and feeds, tooling, things along those lines. And if you notice, the parts and pieces that they're designing are all something that are familiar to them. And we want to make sure that they come away with a knowledge of how these things work. Eventually, they'll get to designing their own bearing glands if they have to. But if you start with a bearing gland, you kind of lose a little bit of, impetus to really dig in deep. And that's the key to student achievement in this type of education, is they're very fascinated by everything they're working on, so they work a lot harder. I always tell teachers they shouldn't be the hardest working one in the room. Quarter 3 is all about automation and planning for automation. So there are some pieces, where they learn, different chunks of automation, and it's all based around a Siemens PLC. So they actually learn what's used in industry, and they can control very small things to very large things. And so we tried to find projects that would speak to students about their daily lives. And so we designed a series of projects. And if you look, on the left-hand side, it says select one of the 3 projects. So they're really only going to take one. And it allows them to, discover the programming process, how logic works and that type of thing. And then you're going to pick one of the two projects on the right. So one is on elevator control, and Siemens really designed the first elevator, that was run by an electric motor, and so that we thought that was a really kind of a classy way to bring that in. And then the logic involved for a parking lot gate. How do I put in a number and then end up being able to open the combination? And then quarter four is all about how do we build these systems so they all integrate and talk with one another. So there's an automated pneumatic clamping system, feeding systems, conveyors, and like a work cell. So if you think about an introduction to mechatronics, this is it. So Dick, you want to talk about teacher professional development?
I would love to. Well, with COVID-19 in place at this point, face-to-face training is not available. So we have designed a virtual professional development component. We use both whole class instruction and cooperative learning teams. So what that means is a class size for these virtual trainings are 21 teachers, and we divide them into 7 cooperative learning teams of 3 teachers each. And that's a really good method of instruction, and if you're doing it via distance, it's a good way to get all the students involved in all the learning all the time. And that's the key. You want to guide each of these teams so that all 3 members of the team are responsible for all the learning in the project they're working on. We're offering these trainings on a first come, first serve basis. And in the future, we can deliver it specifically to a larger school system or a specific state. And so there's some various options that we can do. Currently, we're offering it at no cost and to schools or teachers. And if it, we don't know if that's going to last forever, but it is for now. And we're going to be working very hard to model effective distance learning strategies. We all know where we are right now with the virus problem growing in many states, and the likelihood that school will go back to operating this coming year as it did last year is we're not sure. So we need to be ready to be able to do something that is different. And teachers that participate in this will receive a 40-hour certificate of continuing education units. That's because the seat time for the training is 40 hours. And so that's it. Tom, did I miss anything?
Another way we have to help teachers, learn about how to deliver this curriculum to their students is a YouTube channel where we post videos of how to unpack the curriculum, how to approach various lessons installed. It even has a space for questions and answers. So if you need a really quick, quick tutorial on something, we have those available. And so during the school year, you'll be able to access these recordings, and then there'll also be an online component where you work with other teachers, on your schedule. Nobody's got 8 hours to a day to devote to this kind of training. So we've tried to set it up as best we can. We'll be able to also help you one-on-one and small groups to, gain answers to anything that they need. So the YouTube channel is listed here. It's the tinyurl.com/Siemens Design, and that'll take you to this YouTube channel that we've developed. once teachers go through training and they've picked the projects they want to get started with, then, it comes down to, let's get the parts and components that we'll need in order to do the projects that we've selected. So Jim Sheehan at Studica can piece together a kind of a purchase quote for each school. It'll be different depending on the number of students you have and which projects you're going to do and how much equipment you already have. So they're more than willing to work with you. And the last thing that I really want to emphasize here is how to get in touch with either Dick or I so you can get more information. Here's our contact information and our phone numbers, email addresses. You can feel free to text me. I actually, answer text too. So,
and just to add to that, Tom and I collectively have way more than 80 years of experience in this business, which when I think about that, that's pretty amazing. And with the work we did with Project Lead the Way, and when we both worked for the Southern Regional Education Board, we have pretty much been in schools in every state in this country. And we are aware of different kinds of configurations, whether it's a career center, a comprehensive high school, a career academy model, whatever it may be. We have seen them and we know how they operate. So if you or your CTE director or your principal have questions regarding how can this curriculum work in your setting, in your school, with your configuration, if you have questions about your lab, how to lay it out, what equipment you might have that would be appropriate, and so on, we can help you. And just reach out and contact us, and there's no charge for this. So all we're doing here is sitting right now this summer in retirement growing tomatoes in the garden. So give us a call.
all right. So, normally this is the place that we gather, information, but since it's virtual.
Let me add something. I just remembered we didn't talk about. The curriculum has various standards that are identified in each of the projects. The English language arts standard, the mathematics standards, the next generation science standards, the technical standards of the curriculum itself. And so if you're in a school where your school is working collaboratively across subject areas, and if your principal has provided common planning time for teachers of CTE, English, math, and science to work together to maximize a contextual curriculum like this, we have a lot of experience with that and would be more than happy to provide advice.
Yes, so, thanks for joining us. Feel free to reach out if you need to, and we will join you all later.